Hello class, today's lesson covers lessons 10 through 12, lesson 10 sequences and scales, lesson 11 problems about combining and about separating, and lesson 12 place value through trillions in multi-step problems. Go ahead and pause the video if you need to in order to get this copied down into your notes. A sequence is an ordered list of numbers or terms that follow a certain rule. For example, I could have the sequence 1, 4, 7, 10, 13, 16. Looking at the sequence, we should be able to discover what the rule is. In order to go from 1 to 4, we would have to add 3. From 4 to 7, add 3. 7 to 10, add 3. 10 to 13, add 3. 13 to 16, add 3. So the rule here would be add 3. I could also take a look at the sequence 3, 6, 12, 24, 48, and if I look here, in order to go from 3 to 6 I add 3, but in order to go from 6 to 12 I'm adding 6. So we're not adding the same things anymore. So let's rethink this. The numbers are growing, so we could use addition or we could use multiplication. In order to go from 3 to 6, we could multiply by 2. From 6 to 12, multiply by 2. 12 to 24, multiply by 2. And 24 to 48, multiply by 2. So the rule here must be multiply by 2. Once we know the rule for each sequence, we can continue that beyond the numbers that we have. For example, up here I could find the next number in the sequence by adding 3, which would be 19. The next one after that then would be 22, and after that 25. Down here, follow this rule, multiply this by 2, that's 96, multiply that by 2, and that would be 192, multiply that by 2, and it'd be 384. Now, a sequence is an ordered list. So each of these numbers has a particular place. In this sequence, 1 is the first term. 4 then would be the second term. 7 would be the third term. 10 the fourth. 13 the fifth term. And 16 the sixth term. Likewise, 3 is the first term. 6 is the second. 12 is the third, 24 is the fourth, and 48 is the fifth term. Two special sequences that you should know are the even numbers and the odd numbers. An even number is a whole number divisible by 2. In other words, these are whole numbers ending with 0, 2, 4, 6, or 8. Now this isn't a perfect definition because negative numbers are not whole numbers, but it's going to be good enough for today. Odd numbers then are whole numbers that are not divisible by 2. So these would be whole numbers ending with 1, 3, 5, 7, or 9. Likewise, this is not a perfect definition, but it'll work for today. And so you see here a list of odd numbers. A scale is a display of numbers with an indicator to show the value of a certain measure. For example, if we take a look at a thermometer, if down here at the bottom this tick mark is marked as 10 degrees Fahrenheit, and the large tick mark above it is marked as 20 degrees Fahrenheit, and then the top large tick mark is marked as 30 degrees Fahrenheit. Each of these marks indicates the change in the temperature. So I can take a look here and figure out what each one of these means then. If we start at 10 and count up to 20, there's 1, 2, 3, 4, 5 times it increases. Well, going from 10 to 20 is an increase of 10. So 10 degrees increase divided by 5 jumps means that each of those is going up by 2 degrees. So in other words, this must be 12 degrees Fahrenheit, this must be 14 degrees Fahrenheit, 16 degrees Fahrenheit, and 18 degrees Fahrenheit, and so on. If instead my 3 large tick marks are marked as 25 degrees Celsius, 30 degrees Celsius, and 35 degrees Celsius, then I still have 5 jumps to get me up from 25 degrees to 30 degrees, but this time it's only a change of 5 degrees. So a change of 5 degrees Celsius happens in 5 jumps, which means each one of those little tick marks, those little jumps, is 1 degree Celsius. So that makes this 26 degrees Celsius, this is 27 degrees Celsius, 28 degrees Celsius, 29 degrees Celsius, and so on. When talking about temperatures, it would be good to memorize a few. For example, water freezes at 32 degrees Fahrenheit, which is the same as 0 degrees Celsius. Water boils at 212 degrees Fahrenheit, but at only 100 degrees Celsius. Those two cross over between math and science a lot, so I would definitely recommend having those memorized. Your book also mentions normal body temperature, which is about 98.6 degrees Fahrenheit, or about 37 degrees Celsius. We also see scale on a map. But on a map, it's more a matter of measuring a certain length and knowing that that length on the map represents a certain length in real distance. While this may be the scale for one map, this could be a scale for another. Every map's going to be different. So as you look at this, I wouldn't actually copy this into your notes, but just keep it in mind. Lucy had 74 marbles in her collection. For Christmas, her dad got her some more, bringing her collection to a total of 91 marbles. How many marbles did Lucy's dad give her? This story problem is telling us that we have one amount, we're getting some more, and that gives us our grand total. And so, it's going to follow this basic pattern. So if I take a look at the story problem, 74 marbles is going to be the sum. That's the amount I started with. It tells me that she got some more, but it doesn't tell me how many more. So I'm going to go ahead and put a letter in there. And that equals the total. Well, the problem tells me that it was a total of 91 marbles. So from the story problem, I can write this equation. Now, following the fact family method, if you write out the fact family as a side problem, you can find the line of the fact family that tells you how to solve it. And that line would be 91 minus 74 equals x. Do what the problem says. So for many of us that's going to mean a little bit of scratch work. So off to the side, 91 minus 74, I have to borrow. 11 minus 4 now is 7. 8 minus 7 is 1. And so x equals 17 marbles. The thing to keep in mind with these problems is sometimes the story problem will give you the sum and it will give you the more and ask you to solve for the total. If that's the case, then you really only have two steps. Write the equation and add. Simeon began a 500-mile journey. On the first day, he traveled 173 miles. How many miles does Simeon still need to travel? In this problem, we have an amount that we're starting with, so something to start with. There's another amount that's being taken away or being taken care of, and we're left with the remaining amount. So it's a 500-mile journey, so that's the something I'm starting with. So 500 minus, and then the amount that I'm taking away, or the amount that's already been taken care of, well, he's already taken care of 173 of those miles. However, the problem does not tell me how many miles he still needs to travel. And so since it doesn't tell me, I'm going to put in a letter, x. This is one of those problems that I was talking about at the end of the last slide. Here, we have already solved for x. So all we have to do is what the equation tells me to do. So, a little bit of scratch work. 500 minus 173. I can't borrow from 0, so I have to borrow from the 5 to start with. So 5 becomes a 4, makes that a 10. Now I can borrow from that and make it a 9, which makes that a 10. 10 minus 3 is 7, 9 minus 7 is 2, and 4 minus 1 is 3. Therefore x equals 327. Take a look back up at the question. It's asking how many miles. So 327 miles. Hopefully you remember that our place values are grouped together in sets of 3. Each group has a ones, tens, and hundreds place. So the first group of 3 is the ones group, or sometimes called the base group. The next group of 3 is the thousands. Then we have the millions, the billions, the trillions, the quadrillions, the quintillions, sextillions, septillions, octillions, nonillions, and then finally the decillions. If we put all of these together, each group has 3 place values, so that's a total of 36 places that we can name based on these 12 groups. You will be required to know up to the trillions. The rest of these are what I like to call brain candy. You don't have to know them, but if you're interested, there they are. So for example, if we take a look at this number, this first group of 3 is grouped together and separated from the next group by a comma. And so in the ones group, we find the ones place, the tens place, and the hundreds place. My next group of 3 is the thousands group, and so we find a thousands or 1,000s place, then the 10,000s place, and then the 100,000s. After that comes the millions group, and so we have a millions or 1 millions place, the 10 millions place, and the 100 millions place. And then finally, this one all by himself is in the billions group and is in the billions or 1 billions place. Again, notice that the groups are separated by commas and that each group has 3 place values in it, ones, tens, and hundreds. In order to write numbers and words, we're going to use their place values, in particular their place groups. So my largest group contains this 12. So I'm going to start by writing 12. Then I take a look at its group. Well, there's the ones group, thousands, millions, billions. So this is the trillions. So I have 12 trillion. And just as I separated the groups with commas here, I'm going to use a comma in my writing as well. The next group is the billions, but there's nothing there, so it's not really worth mentioning. So we're going to skip it. We go down to the millions, and in the millions I see 716, and that's in the millions group. Comma separates the groups. My next group is the thousands, and in there I've only got 50. So 50,000, comma separates the groups. And then finally the ones group, which is 980. Here I'm not going to put 980 ones, it's just simply 980. So to summarize, to write a number in words, you write the number in that group followed by the group name. 12 trillion, 716 million, 50,000, 980. And I just saw I have a little typo in here. That should just be million there. When writing numbers and words back as numerals, it helps to have your groups memorized. So we're going to start with the largest group here, 120 trillion. Now remember, each group has 3 place values. Well, that's easy with 120. 3 digits for 3 place values. Comma separates out the next group. Now if you have your groups memorized, then you know that after the trillions, the next smallest is the billions. Here I've only got 4 billion, but I need to have 3 place values. So the number 4, being a single digit number, would go right here. And so in these empty spaces, I'll need to fill in zeros. It's important that you put that in the right order, because otherwise you could end up with 400 billion on accident. If we keep going now, we'll have a comma between the groups. So that was the billions, so now we're on to the millions. But what comes next is the thousands, which means we have no millions. So all 3 group place values are going to get filled with zeros. Another comma between the groups, and now I come to the thousands. Well, it tells me 398,000. So being a 3-digit number, that's nice and easy. And that's where it ends in words, but again, we need to have our groups memorized. So I know that the ones group, or the base group, comes after this. Well, since it's not mentioned, it must mean that those last 3 place values are all 0. So to recap, to write words in numerals, we start with the largest group, write it in numbers, making sure that each group has 3 digits, 3 place values, and we make sure that we go from one group to the next smallest to the next smallest, filling any skipped groups with 3 zeros. Our last concept of this lesson is multi-step problems. In these, we're actually going to use a little bit of English to help us solve them. So for example, find the product of the difference between 36 and 12 and the quotient of 36 and 12. The words of and between in English are called prepositions, and the idea that follows after them is called a prepositional phrase. One of the special things about a prepositional phrase is that it can be taken out of the sentence, and the sentence will still be a sentence. So, for example, I can take out of 36 and 12 here, and between 36 and 12 there, and this will still be a sentence. So it would say, find the product of the difference and the quotient. Well, difference tells me I'm going to subtract something, quotient tells me I'm going to divide something. Well, I've also got another prepositional phrase here, due to this of. So, if I eliminate this big, long prepositional phrase, really this comes down to find the product, which tells me I am going to multiply two things. Well, now let's put back in the red prepositional phrase. What am I going to find? I'm going to find the product of the difference. So that means my first number that I'm going to multiply is going to be a difference. And I'm going to find the product of the difference and the quotient. So the second number is going to be a quotient. So we're going to divide. Now, fill in the missing pieces. The difference of what? Well, the difference between 36 and 12. And then the quotient of what? Well, of 36 and 12 again. And now we have an order of operations problem. I'm going to go ahead and let you speed this up a little bit compared to how we normally do these problems. And since we know that we're going to do the parentheses here and the parentheses there before we do the multiplication, I'll let you go ahead and do them both at the same time. So, 36 minus 12 gives me 24, and that's going to be multiplied by 36 divided by 12, which is 3. 24 times 12 now comes to 72. So 72 is my answer, and that's how I'll show my work for problems like this. This skill can be a little tricky, so we're going to go ahead and do a second example. So here, I want to find the sum of 9 and 3. So right there, that's a prepositional phrase. I'm going to chop him out. And the quotient of, well, of is a preposition, so I'm going to get rid of that as well. So if we reread this, now it's find the sum of the sum and the quotient. So, finally, if I get rid of that big, long prepositional phrase there, of the sum and the quotient, then it really comes down to find the sum. So, I'm going to add, well, what am I adding? I'm adding the sum and the quotient. So, I'm going to have a sum and a quotient. Well, the sum of what? The sum of 9 and 3. And the quotient of what? Well, the quotient of 9 and 3. And we're going to go ahead and do the parentheses first. So 9 plus 3 is 12. Bring down your plus sign. 9 divided by 3 is 3. And finish it off. 12 plus 3 is 15. These numbers here and here do not have to be the same. However, your book seems rather fond of keeping the same numbers, which is why both examples look like that.